Please welcome Patrick Feaster.
When I was a preschooler, my mother used to cut records like these out of paper for me. After decorating the label, I'd put one of my fingers in the center hole and use my other hand to spin the disc around while singing whatever music I decided what was supposed to be on it.
Are these on your want list now, Kurt?
Yeah, I bet you don't have any of these. Of course, I understood even at that age that these weren't real records. Real records were made out of vinyl or polystyrene or shellac, things like that. These were just pieces of paper. Obviously, something on a simple piece of paper couldn't be a real sound recording, right? Well, when I grew up, I learned to my surprise that real sound recordings do exist as images on paper. 3 years ago, the playback by the First Sounds Initiative of a phonogram recorded on a sheet of paper in 1860 challenged the long-standing practical distinction between pictures of sound waves and sound recordings we can play and hear. Today, we can listen with a little work to virtually any waveform we can see. So inspired by this development, I asked myself, what other kinds of historic phonogram images on paper there might be out there to hear? What are they? Where are they? What do they sound like? And how old are they? In fact, this is such a vast area that I can only give you a whirlwind tour of it today, a few highlights of an exciting new audio frontier that awaits our exploration. Some of these phonograms are preserved in archives. For example, our access to many of the coolest Scott phonograms is hinged on the dedication of my friend and colleague David Giovannoni in schlepping a flatbed scanner to institutions in Paris. But others were published in books and journals. And so some of what I have to share with you today comes from sources such as Bookfinder or a good old-fashioned interlibrary loan. People often express bewilderment when they hear that the phonograph of Édouard Léon Scott de Martinville was designed to record sound to be looked at rather than played back. But efforts to visualize sound on paper have a long, continuous history and aren't at all limited to Scott and his phonograph. Here are 2 pages from the 1947 book Visible Speech, representing the voice in 2 different formats. On the left, it is an oscillographic waveform of the words, "Who'll be the parson?" At the upper right is a spectrogram of the same words, made in a sound spectrograph at Bell Laboratories.
Who'll be the parson?
One is a graph of time versus amplitude. The other is a graph of time versus frequency. The one can be converted into the other through Fourier analysis. So these are really 2 different ways of displaying the same type of data, barring certain parameters such as phase, and hence I'd consider them both sound recordings or phonograms. Both images are playable, though using different techniques. One important point. By playing images like these, we don't turn them into sound recordings or phonograms. They are that already. Nor do we really realize their true potential for the first time. They serve perfectly good purposes in visual form, which is why people made them. But playing them back does allow us to experience them in a new way and offers us new insights into them, or perhaps I should say, in-hearings. For waveforms, I use a program called Image to Sound, which can play wavy lines with modification and which can also play a variety of other oscillographic formats more directly. For spectrograms, I use a program called Audio Paint. Both Image to Sound and Audio Paint were designed for use in experimental sound art, but I've repurposed them for playing historic inscriptions of sound. I'm not aware of any previous attempt to play back historic sound spectrograms, though if anyone has, I'm sure you'll tell me about it. In any case, we can get quite acceptable sound out of them, in case you have any doubts whether they count as playable sound recordings. This is from that 1947 book, Visible Speech.
She was waiting at my lawn.
Now that was clear enough that we can easily tell that the caption is wrong. The speaker said not she was waiting on my lawn, but she was waiting at my lawn. Although one person who heard one of my earlier playback attempts thought the speaker was saying she was looking at my loins. I call this technique Paleospectrophony, a word so long it won't even all fit on one line. The other recording of the words, "Who'll be the parson," we saw and heard earlier, was reprinted from a book published in 1906 and was the work of Edward Wheeler Scripture, or rather, he used a device like this one to transfer a commercial gramophone disc of the death of Cock Robin to a sheet of soot-blackened paper. Here's another segment from the death of Cock Robin as it appeared in one of Scripture's books published in 1902. The gaps in background hiss occur because Scripture cut out long unmodulated stretches to save space. Here you see he's marked a gap of 60 millimeters. Scripture's plates are visually and conceptually quite similar to the famous Au clair de la lune phonogram seen here, but of course in this case, the image on the paper itself is the original recording. There's no gramophone disc to go back to, and so there's a real motivation for getting the best sound from the paper we can. The playback of phonograms continues to evolve. In the middle here, you see an original waveform image from Au clair de la lune. At the bottom is our playback of 2008 to 9. At the top is a new playback I'll be premiering for you here today, which, as you can see, follows the original wave shape somewhat more closely. But before I play it, I'd like to give you something new to listen for. As you may know, Scott rotated the phonograph cylinder by hand while recording, causing speed fluctuations. We can correct these fluctuations today because he recorded a 250 hertz tuning fork as timecode along the vocal trace, but that same timecode also reveals some interesting things. At the bottom of the screen is a spectrogram of the tuning fork trace. Where the line is lower, the rotational speed was faster. Where the line's higher, the rotational speed was slower. You'll notice some regularity in the fluctuation, presumably reflecting this kind of movement. Slow, fast, slow, fast, slow, fast. It's a fairly natural cranking pattern, but at one point, shown here, the timecode suggests that rotation actually ground to a stop and then restarted. This happened at an interesting point. Here, the vertical white lines mark the slowest point of each rotational cycle. Au clair de la lune, mon ami Pierrot. Then rotation slows to a stop. Scott's probably looking to see how much space is left, then prêtez-moi. Okay, out of room now. So listen for the change in background hiss where rotation grinds to a halt. That was April 9th, 1860. Scott recorded the same selection again 11 days later. Let's listen. The renditions are remarkably similar, but this time Scott didn't stop the machine between strophes. By now, he knew how much of the song he could fit in a phonogram and didn't need to look. By comparing the two versions, we can also see that the rhythm of singing starts out fairly independent of the rhythm of cranking, but ends up in sync with it both times. Mon ami Pierrot, giving us some fascinating insight into what was going on physiologically with Scott while he was singing and cranking. Here's a phonogram of Scott reciting some lines from the play Othello on April 17th, 1860. As soon as I can find my cursor. again, there's tuning fork time code so we can correct for speed fluctuations and hear Leon Scott's actual dramatic declamation. But what would it sound if we couldn't correct the time speed fluctuations? Let's find out. So here's what it's like without any speed correction. So a bit distorted, obviously, but there's still something there. This is still clearly a sound recording of sorts, even without the correction. But now compare that with this, a phonogram of the same recitation without time code from November 1857. These early phonograms without timecode are wonderfully enigmatic, elusive hints of content that the ear can almost grasp, but not quite. What do you think the subject matter was for this study of the timbre of the voice recorded in late 1857? And how about this recording of a song of the voice from July 1857, the oldest known phonogram, longer than a split second? Can you catch some hint of someone singing? Now, as garbled as this may be, it's actually more engaging than most early phonograms on paper, so I'd like to give you a few other examples for perspective. The first published American sound recordings from early 1874. The voice of Alexander Graham Bell from 1875. Anyone recognize this? Okay, it's a print of the tinfoil recording Thomas Edison used to demonstrate the phonograph for the Scientific American in December 1877. Or rather, it's 1/12 of it. The original caption was, "This is a part of the sentences, 'How do you do?' and 'How do you like the phonograph?'" Lest you wonder what a paper print of a tinfoil recording might sound like under better circumstances, here's the word battle, as published in a British magazine of late 1878. Vowel sounds, published that same year by Henry Preece and Augustus Stroh. I think this computer doesn't have the font I used to prepare a lot of these headings, so try to make them out. Here they are. Now, at least they published the whole trace of each vowel. More often, people just clipped a few cycles out of the middle, like this, a snippet of the vowel A, a recording of the voice of someone born in the 18th century, but so short I haven't even bothered to play it. Still, there are other sound recordings on paper out there that, although rather short, are still worth recovering as sound. Here's a modified phonautograph devised by Victor Henson, usually referred to as the Sprachzeichner, or speech drawer. In or before 1886, One of his students at the University of Kiel, Paul Wendeler, used it to make recordings of a number of words as part of a study of consonant sounds. Some were nonsense words like bemo, but others were real German words. Here's Kasse, meaning a cash desk, probably pronounced Kasse, since Wendeler wanted to study the S. That wasn't so successful, but here's Karre, meaning a cart or wheelbarrow. I believe the date 1886 makes these the earliest known recordings of words in the German language. And then there's Eli Whitney Blake Jr. of Brown University, who in 1878 pioneered the use of a membrane mirror and light source to record sound photographically. Here are some of Blake's recordings as published in scientific journals of the time. The content is A-A-E-I-O-U, Brown University, how do you do? Brown University, how do you do? Wouldn't that make a great college yell for Brown University? Now, if you hear that, then we're dealing with, I believe, the oldest known clearly datable recordings of spoken English. But there's a catch. At the Library of Congress, I found a print made from one of Blake's original plates. And I discovered that the published versions had been tampered with, one of the earliest cases of post-production editing of sound recordings. So I thought you'd like to hear the unedited original. So, how do you do? The oldest known clearly datable recordings of a spoken English phrase. His words come echoing down through the ages. About 1908, Dayton Miller, my font again is not being completely recognized here. About 1908, Dayton Miller developed a somewhat more sophisticated device on similar principles called the phonodike, or sound shower. Here's a phonodike recording of Miller saying, Lord Raleigh.
Lord Raleigh. Lord Raleigh.
Another photographic method of sound recording involved the flame manometer of Rudolf Koenig, in which a membrane vibrates and varies the amount of lighting gas fed to a flame. In 1898, Nichols and Merritt at Cornell University published some nice manometric flame photographs of words and phrases, including preposterous, Raritan River, and in homage to the inventor of the flame manometer, Dr. Koenig.
Dr. Koenig. Dr. Koenig.
We occasionally find paper prints of Berliner Gramophone recordings. This example, shared with me by my colleague Stefan Puy, appeared in a German magazine in early 1890. The original zinc disc was actually used as a printing plate. Let's flip the image to get a better look. At the bottom is the date December 14th, 1889, and then R50, which Stefan and I have reason to believe designates a 50 RPM playback speed. Here it is at 50 RPM, counting in German, and then the alphabet. Obviously, the disc was recorded at an ever-varying speed, so if Stefan and I are right about the 50 RPM designation, and I think we are, this might be the oldest surviving intentional trick recording. Here's another paper print of a Berliner Gramophone recording, this one in the Berliner Papers at the Library of Congress. When I first played it back last year, I had no idea what I was going to hear. Something from 1889, but what? Here's how it starts, with a transcription of the German on the left and an English translation on the right, prepared by Stefan Puy, Norman Bruderhofer, and myself.
Also hier ist eine Platte, die Louis Rosenthal mit nach Frankfurt nehmen will. Will die selber Papiertechnik. Vielleicht braucht verschiedene Prozesse, um das zu tun. Ein Prozess ist zum Beispiel, von der Platte einen Abdruck auf Falschpapier zu machen und von dieser Falschpapier verschiebt eine Fotografie auf Film oder anderen Metalle auszuführen. Also heute ist der 11. November 1889 und ich bin hier auf der Bundesstraße Nummer 2a, einem Büro in Hannover.
The idea, as it turns out, was to print gramophone discs on paper, send them cheaply through the mail, and then convert them back into playable form. Here's another excerpt which needs no translation.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's all my opinion. Morgenrot, Morgenrot, leuchtet mir zum Früh und Tod. Bei 40 Trompete blasen, dann muss ich mein Leben jagen, wie so mancher Kamerad.
That last part was Reiter's Morgengesang, which I believe is the oldest known surviving recording of singing in German. As a whole, I also believe this is the oldest gramophone recording that has been played in public in living memory. This print of a Berliner Gramophone disc appeared in an ad in the March 1898 issue of Cosmopolitan, reduced to 2/3 actual size. Chauncey M. Depew from his speech on Forefathers' Day. This scan was made from an original in the David Giovannoni collection. The ad says, place in the zonophone, and this is what you will hear spoken, or what you hear spoken. If someone had actually tried to play this with a steel needle, of course, what they would have got was a chewed up piece of paper. But we can still play it digitally, and no known shellac pressings have been reported of this particular take, 693Z, so the print may be the only surviving version of the recording.
Having arrived in this country among the early settlers, on the one side in New York, on the other in New England, and having fallen in love, and died in the old Scottish woods, without regard to race or creed, I can praise British all, honestly, all the national celebrations.
The speech is at least clear enough that we can detect a mistake in the ad text. Depew does not say side here. So how far back in time do phonogram images on paper take us? Edouard Léon Scott de Martinville's first experiments recording sound with a membrane took place in 1853 or 1854 with brief traces of notes played on a guitar. But traces were sometimes also made directly by vibrating objects. Here, for example, are some records of vibrating strings published in 1870. Let's listen to one example. Whoop. Or maybe it runs the other way around. It's kind of hard to tell. Similar examples, though, can be found predating Scott's phonautograph. Here's an image of a trace made by holding a tuning fork up to an inked wheel, published in 1850. Pretty short, but we can loop it. Here's an even older image published in 1844 based on an experiment of 1842 or earlier. This is supposed to show a trace made by a tuning fork. We can loop that too. Sounds more like a machine gun than a tuning fork. And I suspect it may actually be more of a hand-drawn sketch than an actual recording. But that may not matter if we're trying to find early phonograms in general and not just early sound recordings. In 1996, the World Intellectual Property Organization, WIPO, officially redefined the term phonogram to include, and I quote, phonograms that are not fixations of sounds. Phonograms may be produced, for instance, using digital technology that fixes data which can be used to generate sounds even though no real sounds have yet been produced, end quote. They believed they were modernizing the definition, but examples of synthetic phonograms, which I gather is what they had in mind, can be found dating back quite some time. Here's one from the 19-teens, contrived by Dayton Miller, the inventor of the phonodike. He wrote about this, quote, "Beauty of form may be likened to beauty of tone color, that is, to the beauty of a certain harmonious blending of sounds. You be the judge." This is a waveform representation of a sound as a graph of time versus amplitude. I'd say this is a prime example of WIPO's category of, quote, phonograms that are not fixations of sounds. But there are much older examples of such phonograms. These waveforms from a plate printed in 1806 are supposed to illustrate the concept of beats. I haven't found any waveform depictions of sound from before the 19th century, but rows of dots were used to represent sound wave impulses according to the same logic, a lot like a vertically modulated phonograph recording. And these too can be played as synthetic phonograms. Here's a specimen from 1739. And another from 1677. Played at a few different speeds. And you thought that sound originated with video games in the 1980s. The pulsatory theory of sound itself doesn't extend much further back than this. So for synthetic phonograms in this format, 1677 is the year to beat. But remember, phonograms can exist in two different formats, oscillograms and spectrograms, and we can play spectrograms using the technique I call paleospectrophony. Inscriptions in the spectrogram format date back before the invention of the sound spectrograph, when they were drawn by hand, often after laborious manual calculations. There's the phrase, "Joe took father's shoe bench out."
Joe took father's shoe bench out.
Edward Wheeler's Scripture had this device for measuring waveforms and used it to create pitch contours like this one, based on the same Chauncey Depew Forefathers Day speech we listened to earlier. These may not show sound spectra, but they are in spectrogram format, time versus frequency, and they also illustrate the interchangeability of this format with the waveform format we more often associate with phonograms. Let's listen to a couple examples of pitch contours Scripture drew from recordings he'd made himself on the phonautograph shown here. These are from his article, Records of Speech in Disseminated Sclerosis, published in 1916. Here's one patient saying, "I'd like to go home," first in oscillographic format, then in spectrographic format. Here's another patient saying the same thing. I don't know whether Scripture chose this as a test phrase or his subjects just really didn't like his company. We can find the same basic format used to show the pitch contours of speech as far back as 1775. The idea here was to record the nuances of great oratory. To be or not to be, that is the question. Not a sound recording of speech, perhaps, but is this a phonogram of speech? The same format was also applied to music, for instance, by Milton Metfessel in the 1920s with an approach he called phonophotography. Metfessel recorded vocalists photographically on film with an emphasis on field recordings of African American performers, and then used them to draw charts of the melodies. The original recordings don't seem to survive, but his published frequency charts do, and we can play them just like sound spectrograms. Here's Swing Low, Sweet Chariot by an African American quartet of the 1920s. Some programs worked out on paper for automatic musical instruments, such as barrel organs, used the same time versus frequency format, so we can play them as sound spectrograms too. Here's a well-known effort to inscribe a virtuosic organ performance of the 1770s, Balbastre's Romance, meant to show how precisely the nuances of musical performance could be transcribed in this way. People have reprogrammed this in MIDI, but here it is played spectrographically as acoustic data right off the page. And this approach puts us back before the year 1677. Here's a plate Athanasius Kircher included in his 1650 book, Musurgia Universalis, showing how to pin a barrel organ. That was fairly standard music, but here's another plate from the same 1650 book showing how to pin a barrel organ to play experimental microtonal music. Some medieval musical notation lends itself to the same approach, though by no means all of it. Here's one promising manuscript from before the year 1250. We can play it spectrographically and hear something somewhat like what the marks were originally meant to represent. Now, I anticipate someone objecting at this point. My title is Phonogram Images on Paper, 1250 to 1950. But this is clearly not on paper, it's on vellum. To make up for this misdirection, I'd like to push things back another quarter millennium or so. Here's a manuscript from the late 10th century in Dacian notation, with words meant to be sung on different notes, written on different lines. We may be dealing here with the oldest automatically playable inscriptions in the world. If phonograms can be spectrographic rather than oscillographic in format, and synthetic in origin rather than recorded from life, and if they don't need to have been originally intended for automatic playing by phonograph as phonograms weren't, then it seems these should count. And remember, I'm playing this using the exact same method I used for that 1947 recording of She Was Waiting at My Lawn. Are these 1,000-year-old inscriptions the stuff of recorded sound collections? Maybe or maybe not. But as you decide if and where to draw the line, or indeed where I've gone completely down the rabbit hole, I hope you'll find this journey will help you sharpen your own understanding, not just about what the oldest recorded sounds are, but also about what exactly recorded sound is. Thank you.